In this video, I'm going to cover how we can use the find function to find the intersection of two lines. In this case, we're going to consider a sine function and a cosine function. And our cosine function is going to be phase shifted. So we're going to evaluate these from 0 to 4 pi in steps of pi over 100. And the reason we choose pi over 100 is just to get a smooth looking curve. So we'll say dx is pi over 100 and x is 0 dx 4 pi, 4 times pi. And so our sine function is just sine of x, and our cosine is cosine of x minus pi over 10. And let's just go ahead and see what those look like. So figure 1, plot x sine fun. And I'm actually going to do something a little bit differently here to get both of these on the same plot. And it's this hold on statement. And all that tells Matlab to do is just to hold on to the same figure window, but whatever comes next, just put it in that same figure window. So this is what we get with the graph. And as you can see, it's kind of hard to tell which one is which. So let's add a legend and denote the colors we want. So I'm going to denote the colors using RGB. And if you don't remember what that is, it's not too difficult. It's just something you have to remember. So RGB is typically a 3-column matrix with values that go from 0 to 1. And they specify the red, green, and blue content that you want. So let's make the first line red. So 1, 0, 0. So it has all red, no green, and no blue. And let's make the second line. We'll make that blue. So 0, 0, 1. And so it's always in that order: red, green, blue, red, green, blue. So we'd expect this to be red and this to be blue, and you'll see why that makes sense. And so legend. Well, so another thing with legend, we always use cells. And if you don't remember what those are, I'll show you an example. So let's say word is cat, and let's see what this returns. So here we're saying we want the first subscript of this, and it should return a C. So if we use a cell array, it's a little bit different. We have cat, and that will return cat. So if we say word 1, we get the whole word cat back, and that's different than when we put the first subscript here and we got back C. So that's just a little thing, and I mean it's useful elsewhere, but here we just have to use that for the syntax. So this will be sine fun, and then we'll have cosine fun. Let's make it sine of x and cosine of x minus pi over 10. So cosine of x minus pi over 10. And let's specify where we want it. So location. Let's make that in the northeast. So northeast. And then let's also specify the font size. And I'm going to do a new line here just to wrap it. You don't have to do that, but I like it. It helps you see things a little bit easier. It actually might be better to use it here. So, didn't want to do that. And so we'll have, let's say, font size. We'll make that, I forget what the default font size is, but we'll find out soon what we should make it. Okay, that's good. That looks good. So we can keep that. There's an intersection right around here, near x equals 10, but also sort of near 11. So let's use the find function to see if we can find where this intersection occurs. Okay, so yeah, looking back at this, we'll say, actually, let's do this one instead, because this one's right on 4. Let's find when x is equal to 4. So find x equal 4. And normally this find function will return a subscript for where this would be equal to 4. So for example, if I had like x, let's not do that, z equals 1 to 5, and I had find z equal 5, it should return a 5. And so that's how that works. And so for here, we have find x equal 4, and it returns an empty 1 by 0 matrix. And so what that means is it didn't find any subscripts where x was exactly equal to 4. And the reason that came about was because we used this dx here. You'll just never get exactly x equal to 4. You might have x equal 4.08 or just anything. So the way that we can get around that is by looking for the minimum difference between each value of x and 4. And if that doesn't make a whole lot of sense, let's see if I can explain it. So let's instead say we'll do difference equals absolute value of x minus 4. And the reason that we chose an absolute value is we want to look at values both to the left and to the right. Yeah, I don't know if that makes sense conceptually, good, but if not, try to think about why it does. This is going to give us a vector of the same length as x, each one giving a number for how far away that value of x is from 4. And so intuitively you would think that when this difference is a minimum, that would correspond to the value that's closest to x. So I'm actually going to make this differences. That might make some more sense. So let's see when that minimum occurs. So min differences. Oh, didn't run that. So it looks like the minimum is 0.01. Okay, so next let's find when x is actually equal to 4, or like when x is closest to 4. So the way that we're going to do that is by specifying, so min difference is actually a value that's in this difference vector. So we want to find the position at which this minimum difference occurs. And so again, we're going to use the find function because that will return a subscript for where a certain value is. So find when the differences are a minimum. So, and let's actually store that in a value. So let's say subscript is that. And so let's print that out. Subscripts. And so it returns 128.